Hello, my name is Matt and welcome to another C++ video. 2 years ago, I recorded this video that shows you how to debug C++ and CMake projects in VS Code on Windows WSL. However, my C++ workflow has changed quite a bit and I don't actually use the methods I showed you guys in that video anymore. Things got a little bit easier and a little bit better as well. So I'm here in this video to kind of show you how you should also be debugging your C++ projects. But before we get started, I would just like to ask you to please subscribe to the channel. It does help me out quite a lot. So make sure you hit that subscribe button. Thank you. Now, first things first, let's talk about the extensions that you are going to need in your VS Code. So if we go over to the extensions tab here, I am going to recommend to install the core C++ extensions. And if you just search for C++, you'll be able to see C and C++ here. You're going to install that. It's by Microsoft. And you're also going to install the extension pack right here, which includes a bunch of other extensions such as C++, as you've already seen, as well as CMake and CMake tools. Now, if you've installed these two extensions, you in theory don't need to install the CMake extensions, but you're going to search for CMake and make sure that, the CMake extension for language support is installed, as well as the CMake tools extension is also installed. Now, these extensions should allow you to basically integrate any CMake project into VS Code and to also have syntax highlighting and language support for C++ source code, right? So you can hit F12 and look at the definition of functions and that kind of stuff. And I also want to recommend a particular LSP here if you're on WSL. If you're on Windows, you should probably stick to the C and C++ extension for the language support and debugging stuff. But if you are on WSL or if you're just running VS Code from a Linux distribution, you can install Clangd, which is the Clang LSP, so the language server. And in my experience, this tends to work a lot better than the CPP debug, which is part of the Microsoft C and C++ extension. And we'll talk more about that later. So, if you want to, also install this here. Now, let's briefly talk about the system requirements that you need in your machine as well. Now, if you are trying to debug C++ projects on Windows with VS Code, you have to have the MSVC compilers installed. And the simplest way to get those installed is by basically opening the Microsoft Visual Studio installer and just installing the latest distribution of Visual Studio as well. Even though you're not going to use it, I know it's a waste, but that will install all of the compilers that you need and all of the standard libraries that you need as well. So you can run C++ code on VS Code on Windows. Now, moving over to Linux, and I know that, there isn't just one distribution of Linux here. You are going to need to have a few things installed. Obviously, you're going to have CMake installed in your machine. I would personally recommend CMake 3.25 onwards. But I think that the minimum required version for CMake here is 3.21, and we'll go over why that is in a second. You also need to have a compiler installed, so that is either GCC or Clang. Make sure that you have a reasonable enough version of the compilers just so you can get, the latest C++ standard support. And you also need a debugger, so you also need to have either GDB or LLDB installed. If you install Clang, for example, I think LLDB comes with the whole installation. And if you've got GCC installed, you need to separately install GDB because it probably won't be installed by default. So those are the things that you need. Let's get into it now and let me explain to you guys the sample project that we've got here and how this whole thing actually works. So in the root directory, you can see that I've got a CMake lists file here. And this basically declares, two subdirectories, library and executable. Each of these directories contains a particular library or an executable, and we'll look at that in a second. But importantly, we also pull FMT here, which is a third-party library with fetch content declare. And at the very top, we set the minimum required version of CMake. As I said, it's 3.21 because of the preset stuff, and we're going to be talking about the preset stuff in a second. That's what makes the whole thing work quite easily. We've got a project declaration, as well as setting the CMake C++ standard here, which I have previously explained how it all works in a different video. You can see the link in the description if you're interested. But, this is probably what you're going to be doing in most of your projects. Now, going over to the executable directory here, we simply have a CMake lists that define an executable called executable, and it's basically comprised or compiled from the main.cpp file here. And down here, you can see that the executable actually links against our library, which is defined in the same project, as well as that third-party library FMT. So if you go over to library, just so you can see how it's all defined, we have the library target, which is by default a static library here in a CMake. We have the library.cpp file being compiled into this library, and we have the public headers in, include library here, right? But this is how it all works. And there's nothing too interesting here. You can basically just copy and paste this project and then basically start from there if you want. The link to this repository will be on the description for those who are interested. But the bottom line is, if you have basically copied and pasted this project into your local directory, once you open it with VS Code, you should be able to type Ctrl+Shift+P and do a CMake select configure preset. And from here, you're going to see a bunch of different options, which are basically just, ready to go settings for compilation in VS Code here. So for example, I have Clang installed on my WSL and I want to build in Clangd debug. So I will select the Clangd debug here. So if I select that, you can see that the compiler is already switched to Clangd 17 here, and the build files have been written to, a particular directory, in this case, Unix Deb Ninja here, but I will probably have to rename this after. It'll be something like Clangd Ninja or something like that. But if we do Control-Shift-P and do a CMake build, you can see that the project just builds. It is a debug build, so I can already use the executables and libraries here to debug my program, and we'll get to that in a second. So how does this whole thing work? So how do I actually get this special menu that says, CMake select preset here, select configure preset? This actually works by having a CMake Presets.json file in the root directory of your project, so next to the CMake lists.txt. And if you take a look at this file here, it's essentially just a JSON file that contains a bunch of inherited configurations. So for example, there's a configuration here for including Conan. There is a release configuration, a debug configuration, which has, the debug variables necessary. And at the very bottom here, I actually define the main options that you can select from the dropdown. So I have VS 2022 release. I have some GCC debug Ninja builds, some Clangd debug Ninja builds, and that's essentially, how this whole thing works. If you want to know more about presets and learn how they work, I would highly recommend watching my video on the topic. I'll try to put a link on the description or up here if it's possible. I basically teach you guys how to write your own CMake presets. And also, look at the documentation here. You can see that CMake has a very extensive documentation on CMake presets. And it's quite easy to understand. To be honest, it's nothing too difficult, but check those out. But the bottom line is that we get some pre-configured settings that you can just use here for whatever compiler you have. So either Visual Studio or MSVC compilers, or you have Clang or GCC. Now let's actually get into the debugging part of it. So once you have built your project, once you have actually built it all in debug, which we have in our case here, you can create what's called a launch.json file. A launch.json file is just a configuration file in VS Code that tells VS Code how to debug a particular application. So how it starts up an application and where the source files are and etc. Right? So if you open this little run and debug tab here on the left, you will see hopefully an empty column here. What you have to do is create a launch.json file. And if you get these options here, you can select C++ and GCC. So hopefully you end up with basically an empty JSON file. And what you can do now is you can add a configuration. And there are two different ways of doing it. As I said, if you are on Windows, you're basically going to stick with the CPP tools debugging. There'll be an MSVC version here or a Visual Studio version here. In my case, it's GDB because I am on Linux. So this is the only debugger that I picked up. So I'm going to click on the launch version. So launch is going to basically execute a new application, and you'll see how it works in a sec. The first thing we're going to change is the name. So we're going to just put the name of the thing that we want to execute. I just put executable debug here because the name of the program is just executable. The type here, you should not change this at all. It should just be CPP debug if you are using the Microsoft debugger. Request is launch, and then the program name. So this has to be the path to the executable you want to debug, right? In our case is workspace folder, and we also have it in build, and I believe it's Unix, Deep Ninja, source, and executable here. So let's just put exactly that. And then the name of the executable, which is, believe it or not, executable as well. Now, if you have command line arguments that you want to pass to the program at the debugging time, you can put them in here, right? So I can put something like, hello, or something like that. And this will get picked up by my program as well. This is what args is for. And the rest of it, you basically just, leave as it is. So the important thing you might want to change here as well is the current working directory, which is the working directory when you're debugging the program. If you put file name dir here, this is just going to default to where the executable is located. So in my case, it's going to be this direct up here, as you can see. The me mode should always be either GDB or LLDB if you're on a Linux distribution using GDB or LLDB, but this will probably change automatically on Microsoft if you select the Microsoft configuration. And you can add a bunch more stuff here. Obviously, you can have environment variables and whatnot. And every single one of these options, there will be some sort of documentation here. VS Code is actually fairly good at that. So you can see that environment just means the environment variables to add to the environment for the program. And we're going to basically leave this as is. I'm not going to explain this too much, but just know that you are going to have to use a launch.json so you can debug your stuff. And once this is done, you're going to hit save, and you should now be able to see this name here on the drop-down list here. And this is what you do. This is basically what you do. You just click on play, and then you can debug this freely. And just to show you that that actually works, we are going to hit a breakpoint somewhere in our main file. So let's go into source, executable main. I'm going to put a breakpoint here. Oh, it was already there anyway. And we're just going to hit the debug button, and you can see that I can already step through the code. I can already step into the functions. I can already, go line by line, and do whatever you need to actually debug this. And this is the bread and butter of debugging a kind of modern CMake and C++ project without any hassle. You basically just copy and paste the CMake Presets.json into your CMake project, and you will have all of this done for you automatically. And as a bonus, if you are sort of copying the repository, which has a link in the description, you will also get the launch.json file here for you, which has everything set up for you automatically. Now, before the end of the video, I would like to talk about Clangd a little bit and what benefits you may or may not get depending on whether you're using Clangd or not. So Clangd is essentially a different language server protocol to the one you get by default if you install the C++ tools by Microsoft. It tends to be faster when loading up the project. I get better diagnostics as well. So for example, it does detect when you're not using a header directly in your source file. And it's just little things that may increase your productivity and the quality of your code. So I highly recommend Clangd with LLDB, which means that you are going to have to install a different extension. So as you can see here, Clangd has to be installed and enabled. I'm going to enable that now. So once you have enabled Clangd, you also want to disable the IntelliSense for Microsoft's C++ CPP tools here. You're going to get a pop-up here, just disable IntelliSense. Now, if you miss that pop-up, you can also do it in the settings. So if you go on the settings.json for the workspace, there will be an option. It's called IntelliSense Engine or something like that. And then you just disable it. So this will make sure that the Microsoft IntelliSense is disabled, but Clangd is enabled. What you're also going to do once you've done that is you're going to search for Clangd here, and you're going to download language server if you don't have Clangd already installed in your system. And this will automatically install Clangd on your Linux distribution, and you should have the LSP working. You can reload the window after you do that, and you should hopefully now have Clangd working as your main language protocol here for C++, and things will just work a little bit better. Now, for debugging, you can also use Clangd and LLDB, but for that, you are going to need a different extension, which is called CodeLLDB. This is the one that works the best in my opinion. I have already got it installed here, and it works just like a charm. Which means that when you do a new configuration here for the launch.json, you can also use the CodeLLDB options down here. So you're probably going to click on the launch here if you want to just launch a program. And again, I'm just going to copy and paste this from here because it doesn't matter too much. And the name is going to be executable LLDB debug, right? Now, the CodeLLDB extension doesn't support all of the options that you may get with the CPP debug version. And if you want to see the supported ones, you can just start typing, quotation marks here, and you get all of the supported options, as you can see here. But once you've done that, it's just as easy as, debugging your project in the same way. It's just going to be using a different debugger now. What I actually found with Clangd and CodeLLDB is that it has nicer printers. So when you do something like, including a vector, and you create that said vector in here, and you can see straight away, Clangd working very hard. It already knows that we're not using vector here. So with the Microsoft LSP, you don't get this kind of stuff. But if we were to create a vector here, a vector of integers, for example, and we call it test, and it's a const vector. Now, if we compile this and then debug, the way in which the vector is shown here tends to be a lot nicer, and you can see kind of like the positions of the elements in here. And it's just very, very nice. It's a lot nicer than the default Microsoft. Those wondering how you would integrate something like Conan or VC package here to manage your dependencies, I already have some configurations here for Conan. So if you are interested in that, you should just be able to select, do a CMake, select configure preset, and select the Conan version that will be here. I will fix this. It's not appearing now, but you will be here. And if you don't yet know how to use Conan and you want to learn how to very quickly and very easy integrate third-party dependencies into your project, you should check out this video here. And yeah, just watch all of it. I know it's quite long, but it's worth it. Anyway, that is it for this video, guys. I hope you have enjoyed the content. And if you did so, please subscribe to the channel and drop a like on the video. And I'll see you next time. Bye-bye.